Imagine a world without the internet, GPS, or even electricity. This isn't science fiction, it's a potential reality if a powerful solar superstorm strikes. As tech enthusiasts, we rely on our interconnected world, but understanding the vulnerabilities of our digital infrastructure to cosmic events is crucial. Let's delve into the science, the risks, and the cutting-edge strategies for resilience. Our Sun, a seemingly stable star, is a dynamic powerhouse. It constantly emits a stream of charged particles known as the solar wind. However, occasionally, it unleashes far more potent phenomena that pose a direct threat to our technological civilization. Solar flares are intense bursts of electromagnetic radiation, ranging from X-rays to radio waves. They erupt from the Sun's surface when magnetic field lines twist, break, and reconnect, releasing immense energy. These flares travel at the speed of light, reaching Earth in just 8 minutes. Their primary impact is on our planet's ionosphere, causing immediate radio blackouts, particularly affecting high-frequency HF communications used by aviation and military. Coronal mass ejections, CMEs, are even more concerning. These are colossal expulsions of magnetized plasma from the Sun's corona, containing billions of tons of material. While slower than flares, taking anywhere from 15 hours to several days to reach Earth, CMEs carry a significant magnetic field. When this field interacts with Earth's magnetosphere, it can trigger a geomagnetic storm. The strength of a CME is often classified by its speed and magnetic field orientation, with faster, southward-oriented CMEs posing the greatest threat. The interaction of a CME's magnetic field with Earth's magnetosphere causes rapid fluctuations in our planet's magnetic field. These changes induce electric currents in long, conductive structures on Earth's surface, a phenomenon known as geomagnetically induced currents, GICs. These currents are not part of the normal electrical grid operation. GICs can flow through power transmission lines, pipelines, and even railway tracks. When they enter power transformers, they can cause magnetic saturation, leading to overheating, voltage instability, and ultimately, widespread power outages. The 1989 Quebec blackout, which left millions without power, was a direct result of GICs from a solar storm. The effects of a major solar storm are far-reaching, impacting nearly every facet of our tech-dependent lives. Satellites, the backbone of modern communication and navigation, are particularly vulnerable. Direct radiation can cause single-event upsets, SEUs, flipping bits in memory or processors, leading to malfunctions. Prolonged exposure can cause total ionizing dose, TID effects, degrading electronic components over time. GPS signals, crucial for navigation, timing, and countless applications, can be severely disrupted. Ionospheric scintillation, caused by solar storm-induced disturbances in the ionosphere, can scatter and attenuate GPS signals, leading to accuracy degradation or complete signal loss. Communication systems, from satellite phones to terrestrial radio, face blackouts and interference. The power grid, as discussed, is at risk of widespread collapse due to transformer damage and cascading failures. Even personal electronics, while generally more resilient due to their smaller size and lower exposure, are not entirely immune. Sensitive industrial control systems, unshielded components, or devices connected to long power lines could experience issues. The Internet apocalypse scenario, while extreme, highlights the potential for long-duration, widespread Internet outages if transatlantic fiber optic cables, data centers, and routing infrastructure are compromised by GICs or power grid failures. While national infrastructure hardening is a long-term goal, individual preparedness for tech enthusiasts involves proactive measures to protect personal devices and ensure connectivity during a solar event. The simplest and most effective first line of defense for individual devices is physical disconnection. Unplugging electronics from wall outlets and network cables removes them from the path of potential power surges or GICs. This isolates them from the grid, preventing damage. For more robust protection, Faraday cages offer an elegant solution. A Faraday cage is an enclosure made of a conductive material that blocks external static and non-static electric fields. When an electromagnetic pulse, EMP, or intense electromagnetic radiation hits the cage, the charge redistributes around the exterior, canceling out the internal field. For small electronics, a simple DIY Faraday cage can be constructed from a metal garbage can with a tight-fitting lid, lined with cardboard to prevent direct contact. Commercial Faraday bags, made from conductive fabrics, offer portable protection for laptops, smartphones, and external hard drives. Surge protectors are essential for everyday electrical anomalies, but their effectiveness against a massive solar-induced GIC is limited. Point-of-use surge protectors, typically found in power strips, use metal oxide varistors, MOVs, to divert excess voltage. Whole-house surge protectors, installed at the electrical panel, offer broader protection against grid fluctuations. However, neither is designed to withstand the sustained, low-frequency, high-current GICs that a severe solar storm could induce. They are primarily for high-frequency, short-duration surges like lightning strikes or utility switching events. Proper grounding of your home's electrical system is fundamental. A well-grounded system provides a safe path for excess electrical current to dissipate into the earth, reducing the risk of damage to appliances and electronics. For sensitive home lab equipment or server setups, dedicated grounding rods and isolated ground circuits can further enhance protection against electrical noise and surges. A major solar storm could lead to prolonged power outages and communication blackouts. Tech enthusiasts, often reliant on constant connectivity, need to adapt their preparedness strategies. Beyond the standard non-perishable food and water, a tech-focused emergency kit is vital. Include multiple power banks, fully charged, for mobile devices. Solar chargers with high-efficiency panels can provide sustainable power for smaller electronics. Hand crank or solar-powered radios are crucial for receiving emergency broadcasts when traditional communication fails. Consider a satellite phone if your budget allows and your location warrants it, as they operate independently of terrestrial networks. Backup heating and lighting sources are critical. LED lanterns, headlamps, and battery-powered lights are energy efficient. For heating, consider propane or kerosene heaters designed for indoor use, ensuring proper ventilation. Manual operation of essential systems is often overlooked. Learn how to manually open your garage door, operate electric gates, or flush toilets if your water pump relies on electricity. In a world without internet, access to information becomes a challenge. Create comprehensive offline data backups. Store critical documents, software installers, technical manuals, and educational resources on multiple external hard drives or high-capacity USB drives. Ensure these drives are unplugged and stored in Faraday bags when not in use. Consider burning essential data to DVDs or Blu-ray discs for long-term EMP-resistant storage. Download offline maps, survival guides, first aid manuals, and even entertainment like ebooks or movies onto devices that can be powered independently. Think about a knowledge vault of essential information that doesn't require an internet connection. Beyond individual actions, significant efforts are underway to harden our global infrastructure against solar superstorms. These initiatives often involve cutting-edge technology and international collaboration. Forecasting space weather is paramount. NASA's TRACERS mission, for example, uses twin satellites to study the fundamental processes of magnetic reconnection, which drives solar flares and CMEs. Understanding these mechanisms improves our predictive capabilities. NOAA's Space Weather Prediction Center, SWPC, utilizes a network of satellites, including the Deep Space Climate Observatory, DSCOVER, positioned at the L1 Lagrange point, to monitor solar wind conditions and provide crucial advance warning of incoming CMEs. These systems give grid operators and satellite companies precious hours to prepare. Protecting the power grid is a complex engineering challenge. Strategies include installing specialized GIC blocking devices, which act as filters to prevent geomagnetically induced currents from entering transformers. Upgrading older transformers with more resilient designs that can withstand magnetic saturation is another long-term goal. Implementing advanced monitoring systems that can detect GICs in real time allows operators to take proactive measures, such as temporarily reducing voltage or reconfiguring the grid to minimize damage. For satellites, electromagnetic shielding is crucial. This involves designing spacecraft with conductive enclosures and using radiation-hardened components that are less susceptible to SEUs and TID effects. Redundancy in satellite constellations, where multiple satellites perform the same function, ensures that if one is damaged, others can take over. Developing autonomous satellite systems that can detect and mitigate solar storm effects without ground intervention is an active area of research. The concept of a resilient internet involves creating more decentralized and robust network architectures. This includes exploring mesh networks, which allow devices to communicate directly with each other without relying on central infrastructure. Research into alternative communication methods, such as high-altitude platform stations, HAPS, or even low-frequency radio communication, could provide backup channels during widespread outages. The goal is to build a network that can fail gracefully rather than collapsing entirely. Individual preparedness extends beyond just protecting your gadgets. It's about cultivating a mindset of self-reliance and informed action. Develop a comprehensive emergency plan with your household. This should detail communication strategies if cell networks are down, designated meeting points, and roles for each family member. Practice this plan regularly. For tech enthusiasts, this might include setting up a local area network, LAN, for communication within the home, or even experimenting with amateur radio for external communication. Regularly back up all critical data. Implement a 3-2-1 backup strategy. 3 copies of your data on 2 different media types with 1 copy off-site. For solar storm preparedness, ensure at least one of these copies is physically disconnected and stored in a Faraday cage. Consider encrypted cloud backups for data that isn't sensitive to potential internet outages, but always have a local, offline copy. While we focus on technology, basic survival skills become paramount when technology fails. Learn how to purify water, administer first aid, build a fire, and navigate without GPS. These skills empower you to thrive even in a disconnected world. Consider joining local amateur radio clubs or emergency preparedness groups to learn practical skills and connect with like-minded individuals. Knowledge is your greatest asset in preparing for solar superstorms. Stay updated on space weather forecasts from reputable sources like NOAA's Space Weather Prediction Center, SWPC, or NASA's heliophysics missions. Many apps and websites provide real-time data on solar activity, including flare classifications and CME predictions. Understanding the different alert levels, for example, G1, G5 for geomagnetic storms, will help you gauge the severity of a potential event. Pay close attention to official alerts from emergency management agencies regarding potential disruptions to communication, power, or navigation systems. These alerts provide crucial lead time for you to unplug sensitive electronics, activate your emergency plan, and prepare for potential outages. Share this information responsibly within your community. While the likelihood of a catastrophic internet apocalypse from a solar storm remains low, the potential for significant disruption to our tech-dependent lives is real. As tech enthusiasts, our understanding of these threats and our proactive preparedness can make a profound difference. By combining scientific knowledge with practical resilience strategies, we can navigate the challenges of space weather and ensure our digital future remains bright, even if the sun throws a cosmic curveball. Are you ready to fortify your digital life against the next solar storm? Share your preparedness strategies in the comments below, subscribe for more insights into the future of technology, and hit that notification bell to stay ahead of the curve. Let's build a more resilient future together.